I'm going to turn it over to Lindsay. Again, Lindsay is new to Rexel, Western New York, but not new to Rockwell. He's a longtime employee of Rockwell. So Lindsay, if you want to just do a brief introduction of yourself and your role, please.
Yeah, thanks, John. Appreciate it. So yeah, guys, my name's Lindsay Henton, and for those of you who knew Brian Blaisdell as the power control area manager out there in Western New York, I was his counterpart here, based out of the Cleveland area. Once again, for reference, Brian isn't going anywhere. He's still going to be around on the power control side of things. I'll just be helping with Rexel over here on more of the commercial side of things moving forward. As John kind of mentioned, I've been with Rockwell for about 8 years now. I actually started off my career with Rockwell as a field service engineer, focusing around PLCs, motion, and drives. And about 3 years ago, I took over the PCAM role for the Cleveland territory. Now in my current role, I'm the power control business lead, so supporting the different APRs within the Western New York and Ohio territory, and work with William and John very often. So if there's any type of commercial issues or anything along those lines, just wanted to make sure you guys were aware of who I am. Once again, I'll be working with William and John, but I wanted to at least introduce myself, as I hope to work with some of you guys here in the near future. With that being said, that's all I got for you, John. So I guess I'll turn it over to William.
All right, fantastic. Thanks, Lindsay. Thanks, John, for the introduction. All right, guys, welcome to my AC applications, drives, and installations best practices little tech talk here. Let's go ahead and get started. So our agenda is going to be just applications and best practices. For the first function here, we're going to go over VFD theory, your function, and install. But before we get started, though, you kind of have to ask yourself the question first before we get into this. What is a VFD? So let's first understand, how does a VFD work here? You have 3 sections inside the VFD. John, can you see my my cursor? Or Lindsay?
Yes, we can.
Okay. So let's first understand how a drive actually works here. So we have 3 sections inside the VFD. You have the converter section, the DC bus, and the inverter section. For your converter section, this is going to take, just for this example right here, your 3-phase AC power. We got it here for 480 volts, and that's going to convert that over to DC power. Next, your DC bus is going to store this, and it's going to filter that DC power into the large bank capacitors, and it's going to chop that over into the inverter section of the VFD. And then lastly, which is kind of funny, because whenever you take a look at the VFD, it's going to take in AC waveforms, turn it into DC, and then with the inverter section of the drive, it's actually going to turn it back into AC. But it's not really true AC, though. It kind of imitates what a sine wave looks like here. And that's going to be through pulse width modulation. So what is pulse width modulation? This is basically what the AC motor sees whenever it is done converting that DC power over into usable AC. With the VFD, it can vary this output based on its hertz reading. So you can go from 1 hertz up to 60 hertz, either turning the motor faster or slower. So as we can see right here, as the sine wave gets closer, our AC hertz output is going to be at a higher frequency, and as it extends, it's going to make the wavelength longer, resulting in slower speeds and slower hertz of the turning of the motor. So let's take a look at VFD application types and some best practices. So we have 2 ways of sizing the VFDs. You have constant torque versus variable torque. So what's the difference between constant torque and variable torque? And do we know what the differences are when it comes to sizing drives and speccing them out? Well, we have to ask a couple of questions first, though. So what is the application that the drive is going to be controlling, and what are the requirements for this? If you're like me, you're having to look for answers online all the time. So let's first take a look at constant torque, which is also known as heavy-duty applications. Which of these applications do we think is constant torque or heavy-duty? We got a conveyor on the left, and then we have a pump on the right. So which of these would be a constant torque application? Just give you a few seconds here to think of the answer.
They're mostly on mute. You can put in the chat if you want the answer.
So our constant duty or constant torque application is going to be the conveyor on the left. Let's take a look at two more applications here. We have a pump application on the right, and we have an extruder on the left. Heavy duty application. Again, your heavy duty application is going to be on the left, or the extruder application. So let's go ahead and take a look at variable torque, also known as normal duty. Which of these do we think is a variable torque application? Got an HVAC unit on the left, and you got a rock crusher on the right. So our normal duty application is going to be on the left. It's going to be our HVAC. Take a look at one more here. We've got a fan on the left, and we have a press on the right. Which of these do we think is a variable torque application? Almost the same thing as the last slide that we asked questions about. The variable torque application is going to be on the left, our fan. So let's take a look at some application guidelines here. So for your variable torque applications, it's going to be essentially everything that's going to be clean water applications or any types of fan applications. And your constant torque or your heavy duty applications, that's going to be everything else. If you look at the matrix here, we have a list of all the types of applications. Well, maybe not all of them, but quite a few that'll cover most that that our customers will come in contact with. Agitators, fans. So if we look at our constant torque here for our speed characteristics, we've got all these applications here as constant torque. But if you take the small list of variable torque applications, I'll have to remember to pull up the reference. This is from an engineering handbook. All of our variable torque applications, fans and pumps, dryers, another type of fan, HVAC, also another type of fan. So it's pretty easy whenever it comes to determining the needs of your application and how you should specify your VFD. So again, anything that's going to be variable torque or normal duty, that'll be your clean water applications and your fans. And for your constant torque or heavy duty applications, that'll be everything else. So inside of the VFDs, we have MOV jumpers. You got your PEA and your PEB jumpers. Now, you might ask yourself, what do I need to know this stuff for, or why do I have these inside of the VFD? So depending on the type of grounding situation that you have at your installation, if you have a non-solid ground or if you have a solidly grounded transformer, for your non-solid grounds, you're going to have these jumpers disconnected. If you have a solidly grounded configuration at your facility, then you're going to want to have these MOV jumpers installed on the VFD. Here's just a couple of the benefits if you have the correct configuration too. And also, it's important to note that if you don't have these MOV jumpers, or if you do have them installed and you don't have it based correctly on the type of grounding situation that you have, then that could cause premature failure of your VFDs. But here's just a couple of the types of groundings you can have. You have a Y delta. So wiring guidelines. So whenever it comes to installing your VFDs, you have a couple of different types of wiring here. You can use shielded, unshielded, such as THHN, THWN. But some of that can make a difference when it comes to putting this stuff in. So for your input power cables, there's really no special requirements. You have nothing sensitive that could interfere with that. Obviously, that's just going to be your incoming power. But with your motor cables, though, this will all depend on your motor lead lengths. You could use shielded or you could use unshielded cabling, but we'll get into that in the next couple of slides. For your drive I/O cables, you have no special requirements. Now for your analog and signal cables, you're going to want to use shielded cabling. You also want to do that with your encoder cables as well too, using shielded cable. I have a couple examples here on the left. Next portion here is drive protection. The next thing that you might want to consider is installing line reactors on the input or the output of your VFD. Now it can depend on the installation on whether or not you might need this or not. So at the input of the drive, you might want to consider line reactors if your power exceeds over 10 times what the VFD's power is rated for, or 20 times that if you have a DC link choke. You have to look here on the top right image here. That's just going to be coming on the input side of your VFD. You also might want to consider installing reactors on the output of your VFD as well too, especially if you want to comply with IEEE 519, and if you have any issues with noise or harmonics. Here's just a couple of the line reactors that you'll see. This just goes into more detail about reflected wave and harmonics that you might experience, just depending on your lead lengths from the VFD to your motor. You can have vastly shortened motor life. Now you might ask yourself, do I really need these though? That's kind of a hard question to answer, but all it comes down to, it depends. Let's take a look at an example. So I just have a couple of our VFDs highlighted here, the 753 and the 755, rated at 400 volts. So if we're using an inverter rated motor at 1488 volts insulation rating, we have no solution on this, and we're not using a line reactor or anything like that. Depending on your frame size, or not your frame size, but your power rating. Where's my cursor here? Go back. So we have a maximum of 1,200 feet when it comes to this. And we have an entire matrix too on whether or not you're gonna require line reactors on this. Next thing to consider whenever you're installing VFDs is your environmental considerations. A couple of questions to ask for yourself. Where's the VFD being installed? Is this going to be a panel mounted VFD? Is it going to be installed on the wall? What am I going to need for that? So what is the atmosphere like that this VFD will be installed in? Is it an caustic, acidic environment? Do we have a lot of dust? Is it in an electrical room isolated from everything else, which would be the most ideal? And then lastly, what is the ambient temperature like? or the temperatures where this VFD are going to be installed. Is it going to be hot? Is it going to be cold? But with most folks, it's going to be dependent on your heat. So a little bit more reiteration on heat. We want to keep the drive as cool as possible. You want to ensure proper airflow and we don't have any sort of hot spots. We have a couple of guidelines established for this too, so that you can determine the appropriate lengths above and below for clearances for our VFDs. And you never want to exceed the temperature ratings that are published. For every 10 degrees Celsius above your drive's rated temperature rating, it will reduce the drive's life by half. What I see a lot of times is whenever a VFD specification is written, it's going to be set to run at 104 degrees Fahrenheit, which that's the maximum that we can go for with the VFD. That's only going to allot for 5 years of life. So the more temperature or the cooler that you can keep it in the enclosure or where the VFD is, the longer that it's going to last. So 104 degrees Fahrenheit is only good for 5 years. So when it comes to those extreme situations that we talked about, you have a couple of NEMA considerations. For example, you have type 1, which is going to protect from falling dirt, stuff like that. For example, NEMA 12, where it's going to protect your drive from dust, falling dirt, non-corrosive liquids, all the way up to 4X, which will provide protection from your corrosion, dust, rain. So here's a real quick picture of a nice clean installation of the VFD. You can see your protection. We don't have any line reactors because this VFD is installed close to the motor, so we don't suffer any loss or reflected wave from the lead links on this. And here on the right is the wiring for that. Another thing to note too, whenever installing your VFD, the VFD has 2 grounds inside of it, one for your incoming line, and that's going to be on the left side of the VFD, and the one on the right side of your VFD is for the grounding termination on your motor. Whenever you're grounding your motor to your VFD, you want to use that instead of, say, installing it on any other type of ground that you might have in the system. Install it on the ground side of the VFD on the right. So a real quick overview here. For your AC power supply, ensure that you have the proper configuration when it comes to your power jumpers, whether you have a solid grounded, or a high resistance ground. You might want to consider removing those jumpers. For your input powering condition here, like I said before, if you don't have any line reactors, just make sure that your transformer in the facility doesn't exceed 10 times the kVA of what the drive is rated for, which you can find close to the catalog number of the VFD, or 20 times that if you have a DC link choke. Surge suppression, make sure you have proper surge protection installed on your VFD, installed on all your coils, your contactors, solenoids, relays, etc., so it doesn't interfere with your drive. Grounding and bonding. Whenever you are grounding your VFD, ensure that some of that paint that you have your grounding cable attached to has that paint scraped away so that we're solidly grounded to the system. Verify your ground wires run for your motor directly to the drive. Like I stated before, you have that ground on the right side of the VFD that should be installed on that. For your mounting considerations and environment, consider the ambient temperature that you're going to be running at as well as the type of environment that the drive might be installed at. So if you got a lot of dust or anything like that, I would consider a NEMA 12. Or if you've got gases in there or anything that can cause corrosion, especially if you're using copper, you want to have a NEMA 4X so that doesn't corrode the leads from the wiring to the VFD. I've seen that plenty of times. For your control signal and cabling, make sure that we're using the proper type of cabling, as well as crossing your wires at 90 degrees. You also want to separate your high and low voltage wiring. There's a lot of noise that's being generated by these VFDs, so we want to keep those isolated. And whenever we are using analog or analog signals or encoders, always keep that separated and use shielded cabling. For your dynamic, we didn't touch base on dynamic brakes, but this one's pretty easy. You just want to ensure that it's installed on your BR plus and your BR negative on the drive, which is also a spot where you can measure your DC bus voltage. Motor cable wiring, again, ensure that we're using the proper wiring from your drive to your motor. And you might not need shielded cabling for this. It's all just going to depend on the distance from your drive to the motor. And with your encoder feedback signaling, like I've said before, just make sure you're using the shielded cabling. Keep your wiring separate from your high voltage lines. You might ask yourself, where can I find all this information? We can find it in the wiring and grounding guidelines for pulse width modulation AC drives, which is going to be your bread and butter when it comes to installing VFDs. And your 1321 power conditioning products. So anytime you might need line or load reactors, here at the bottom, you can see the publication numbers. If you follow these guidelines, you can easily extend the life of your current systems, and you don't have to worry about installing drives and reprogramming them every 1 to 3 years, which is a common thing that I see in the industry. And that's all I got. Do we have any questions?
I don't think there's anything in the chat yet. I just put out the poll. So, Lindsay, did you want to say anything?
No, I just wanted to say great job, William, and especially covering some of the important content, I should say, especially around the jumper configuration. I know sometimes a lot of that gets lost in translation, so that's a very important thing to keep in mind when installing new drives, whether it be 750s, 520s, or any of our drive products. So great job.
It's a lot, I'll say it. It's a lot of the small things that can make or break a system, and a combination of those things.
Completely agreed.
William, do you have a moment to give out your cell or your email address in case anybody wants to talk to you offline?
Yep, I will throw my contact information in the chat for this meeting, and then when you guys, if whatever collateral you send out afterwards, please feel free to send my info in there as well.
Great. Same for you, William, if you want to give your contact information as well.
Yep, absolutely. And the guy's muted. If you need assistance sizing this stuff, we can work together and we can do the math and we can figure out the calculations to actually size this stuff properly and determine if your system might even need it, because your systems might be okay and you don't call for it, but it's a good thing to just check in. I'm more than willing to work with you and discuss these things. Let me go post my information here.
We got it, Lindsay. Thank you. So the poll is up. If you could vote in the presentation, and then Lindsay's contact information is in there as well as William's as well. Otherwise, if anyone doesn't have any question, they want to unmute themselves right now and we'll answer it. You don't have to necessarily put it in the chat.
I know it's a lot of information to take in at a very short time, but my email is posted there. You can always feel free to send me an email asking any questions that you might have about power and cabling, or give me a call too.
And the presentation would be available if you want. Just contact William and he can, there's no confidentiality on that. We can send that to you if somebody wants to review it.
Yep.
Okay, I think that's it, guys. Thanks, Lindsay. Thanks, William. Thanks for everybody that attended. Look for our next one. I think we're taking a week off here. Next Tech Talk is next Tuesday on networking, cybersecurity networking. So pretty excited about that. All right. Have a great day and a great week, people. Thank you.